We're continuing to find the solutions of inequalities and writing the solution sets in the four different types of notation. So let's look at some more examples. Let's say we have the inequality minus 0.25x is less than or equal to 1. All right, let's go ahead and solve for our variable by dividing both sides by minus 0.25. Minus 0.25. That's going to cancel on this side, so we're going to be left with x, and we're going to flip our inequality sign because we're dividing by a negative, so this less than or equal to becomes a greater than or equal to, and 1 divided by a minus 0.25 is minus 4, and that's our solution set. We want to write our solution set in the four different types of notation. Well, we usually already solve for our inequality notation, which is our first type, so let's go ahead and just write that formally. X is greater than or equal to minus 4. We also have set notation. Set notation is read as the set of all values x such that x is a real number that is greater than or equal to minus 4. That's set notation. Our interval notation, we're including minus 4 in our solution set, so we are going to have a bracket at minus 4, which means we include minus 4, and we're including all the numbers greater than minus 4 to the right of minus 4, which goes off into positive infinity, which is always accompanied by a parenthesis sign because we never include infinity in our solution set. And the fourth way, we have a solution graph. This is the fourth notation to express, fourth different way that we can express our solution set. So let's go ahead and put minus 4 right in the middle. We have minus 3, minus 2, going in the other direction. Okay, so we're including minus 4 in our solution set, so we have a bracket here that we're going to put at minus 4. And we're shading to the right, so it's going to open to the right. And we're including all the numbers greater than minus 4 in our solution set, so we're going to shade to the right. And that is our four different types of notation for the solution set of this inequality. All right, let's do a couple more. Let's say we have the inequality minus 2x is less than minus 10 over 3. All right, so let's go ahead and solve for x. We can divide by minus 2. We do so because we want to solve for a positive x and not a negative x. These two terms cancel, which gives us x on the left-hand side. We're dividing by a negative, so we're going to flip our inequality sign from less than to greater than. Let's go ahead and write out another step since we got a fraction in the numerator. Let's go ahead and write a fraction in the denominator, minus 2 over 1. This becomes x is greater than minus 10 over 3. We don't ask why, but we flip the second and multiply. We should be very familiar with this. So we're multiplying by minus 1 over 2. We're just flipping this fraction here and then multiplying. So we have x is greater than, these negative signs cancel, 10 over 6. Positive 10 over 6 is the same thing as, if we factor out a 2 out of the top and the bottom, we have 5 over 3. So x is greater than 5 over 3 is our solution in inequality notation. Our solution in set notation is the set of all values x such that x is a real number greater than 5 over 3. Our interval notation, we're not including 5 over 3, but all the numbers greater than 5 over 3, so we're going to have a parentheses at 5/3, and we're including all the numbers bigger than 5 over 3 all the way to positive infinity, which we put a parenthesis sign at. Okay, not a whole lot to this. We just want to get very familiar with writing these different notations for our solution set. This is called a solution graph. We're going to go ahead and put in the middle right here, we're going to put 5/3. Okay, and we're going in the positive direction, so if we add 1 to 5/3, we get 5/3 plus 3/3, which is 8/3. Then we get 11/3. Then we get 14/3. And if we're going in the opposite direction, we're taking away 3/3, so we get 2/3. We get minus 1/3, minus 4/3, and so on and so forth. All right, so simple adding, subtracting fractions, which should be really good at by now. All right, so we have 5/3 right in the middle. We have a parentheses here. It's going to open to the right because we're going to shade to the right and not include. We're going to exclude 5/3 and include all the values that are greater than 5/3. All right, so here's our 4 ways to write our solution set. These 4 notation. All right, let's do a couple more. Let's take a look at the following inequality. We have 2 over 11, or 2/11 times x is greater than 5 over 2. All right, so let's go ahead and solve for a variable. We can do so by multiplying by the reciprocal of 2 over 11, which is 11 over 2. This term will cancel, just leaving x on this side, which is greater than 11 over 2 times 5 over 2 is 55 over 4. And that is our solution given in inequality notation. X is greater than 55 over 4. Let's go ahead and write it in set notation as well. That's our second way. The set of all values x such that x is a real number greater than 55 over 4. Again, we say real number because we're not dealing with irrational numbers. We don't say rational numbers because rational numbers is actually a subset of real numbers, and we'll talk about that later in a proofs course, but 55 over 4 is a rational number, so it's included as a real number. Hope that made sense. So we have interval notation as well. Here we have x is greater than 55 over 4, so we're not including 55 over 4 in our solution set, so we put a parentheses, and we're including all the greater numbers of 55 over 4. So we're including all the numbers going out to positive infinity, which we place a parentheses at every time. And now we have a solution graph as our 4th notation to write our solution set. So let's put 55 over 4 in the middle. 55 over 4. Let's go ahead and write out a couple more. We have 59 over 4. And we have 63 over 4. We're just adding 1, moving by a space of 1. And in the other direction, we have 51 over 4. Oh, excuse me. And let's go ahead and write one more. We have 47 over 4. 47 over 4. Okay, so 55 over 4 is not included in our solution set, so we're going to have an open parentheses. It's going to open to the right because we're going to shade to the right. We want to include all the values that are greater than 55 over 4, and this goes all the way out to positive infinity. All right, so very straightforward. Let's just do one more example just to really bring it on home. Let's say we have the interval, or excuse me, we want to find the solution interval for the inequality minus x is less than or equal to 0. All right, this is a kind of funny looking inequality. We really don't have to do anything because we can multiply both sides by -1 or divide both sides by -1. So there's not a whole lot to it. These two negative signs cancel. Since we're dividing by a minus sign, we're going to flip the inequality from less than or equal to greater than or equal to, and nothing on the other side changes. It's still 0. So x is greater than or equal to 0 is the inequality notation for our solution set. Let's go ahead and write the set notation. So the set of all values x such that x is a real number greater than or equal to 0. That's our set notation. Our interval notation, we're going to include 0 in our solution set, so we're going to have a bracket of 0. It's going to open to the right because we're including all the numbers greater than 0. So it's going to go out to positive infinity, which we always place a parentheses around. So let's go ahead and see what it looks like on a solution graph. This goes to negative infinity, this goes to a positive infinity. We have 0 in the middle, so we have 1. Let's go ahead and just write a few more places on each side. 0 is included in our solution set. Our bracket is going to open to the right, and we'll shade everything to the right, which is the set of all values greater than or equal to 0, and this makes sense because x greater than or equal to 0, as long as we plug in 0 or a positive number, this inequality would hold true. As long as we don't plug in a negative number, this inequality will be accurate. So we're solving inequalities and we're practicing writing 4 different types of notation for our solution set. We'll actually move on in the next video to solving multi-step inequalities, and then we'll move on to compound inequalities and some applications of that. So I'll see you soon.